Assalamualaikum and hello. So, I would like to talk about the introduction of our presentation, which is radar. Radar is actually a short form that stands for radio detection and ranging. In simple words, radar is an electromagnetic system that used to detect and locate objects. The term detection means radar can identify whether a target is present or not. And the target can be either stationary or moving. Then, ranging refers to measuring the distance between the radar and the target. Radar technology actually started to develop before World War II, and it later contributed a lot to the growth of microwave technology. One important advantage of radar is that it can still work in conditions where human vision is weak or limited. For example, in darkness, fog, haze, rain, and snow. Because of this ability, radar has become very useful in many areas such as aircraft navigation, weather monitoring, military system, and object tracking.
My name is Marwan Yuvaldi Hisham, and I will talk about component of radar system. First component is antenna. The antenna transmits RF pulses into the atmosphere and receives reflected echoes from targets. The next is transmitter. Transmitter generates high-power RF signal pulses for detection. Next is receiver. Receiver amplifies the received echo signals and filters out background noises or interference. The last is display unit. The unit visualizes processed data on a screen. There is PPI to show target range, bearing, and relative position. That's all for the component radar system.
The word radar was coined in 1940 by the United States Navy. It stands for Radio Detection and Ranging. Radar uses radio waves to detect the location of objects like airplanes in the sky. A device called a magnetron generates high-powered radio waves. An antenna focuses these waves into a narrow beam and continually shoots them into the sky. The radio waves travel at the speed of light until they hit an object, like an airplane. The waves bounce off the airplane and travel back towards Earth. Some of the return waves are captured by the antenna, and the data is processed by computers. Based on the strength and travel time of the radio waves, a computer determines the location of the airplane. The airplane's location is then displayed on an air traffic controller's screen. This is how radar helps air traffic controllers track the location of airplanes in the sky.
To begin with, let's look at the first stage of radar operation, which is the transmission of radio wave. Radar system use a transmitter and an antenna to generate electromagnetic radio wave and direct them toward the target object. This wave travel through the atmosphere at the speed of light and can cover very long distance. Moreover, because radio waves are able to operate in fog, rain, and darkness, radar system can detect objects even when visibility is poor. Next, when the transmit radio wave encounter an object such as an aircraft, ship, or vehicle, part of the wave energy is reflected back toward the radar system. This process is known as reflection. The reflect waves are then received by the radar antenna for the analysis. In general, the strength of the reflect signal depends on the size, shape, and material of the object. Therefore, larger or metallic objects usually produce stronger reflection and are easier. Moving on to the echo concept, the reflected signal that returns to the radar is known as an echo. This echo contains important information about the target object. By measuring the time taken for the echo to return, the radar system can determine the distance between the radar and the object. In general, stronger echoes indicate that the object is either larger or located closer to the radar system. Now, let's see how radar detects objects. First, radio waves are transmitted from the radar antenna. Then, these waves strike an object and are reflected back as echo. After that, the radar receiver collects and processes the returning signal. Finally, the processed information is displayed, allowing the radar system to determine the object distance, direction, and speed. This entire process happens within a fraction of a second, making radar an efficient tool for tracking moving
Now
targets.
that we understand how waves reflect, let's look at how we actually measure distance. This is done using the time delay principle because radio waves travel at a constant speed. The speed of light is 3 times to 10 power of 8 meter per second. We can calculate distance by timing how long a path taken to return. As you can see in the formula, d equal to c times 2t over 2. We multiply the speed of light by the time delay. We divide it by 2 because the signal has to travel to the target and back. We only want the one-way distance. For a quick example, if a radar detects an echo returning after just 10 microseconds, our calculation reveals that the object is exactly 1.5 km away. This simple but powerful math is what makes radar such a precise tool for navigation and safety.
Radar technology is widely used in many fields today. 3 important applications of radar are aviation, maritime navigation, and traffic control. First, radar in use in aviation. Air traffic control uses a radar system to monitor the position, speed, and direction of aircraft. This helps ensure safe takeoff and landing operation and prevents collision between aircraft. Radar is especially important during bad weather or low visibility conditions. Second, radar is widely used in maritime navigation. Ships use radar to detect other vessels, coastlines, and obstacles in the surrounding area. This allows ship operators to navigate safely, especially during fog, heavy rain, or at night when visibility is limited. Radar helps reduce the risk of accidents at sea. Third, radar is used in traffic control. Police officers use radar speed guns to measure the speed of moving vehicles. This helps enforce speed limits and improve road safety. Traffic management systems also use radar sensors to monitor traffic flow and reduce congestion on busy roads. So, in conclusion, radar plays a vital role in transportation and public safety. Its ability to detect and track objects accurately makes it an essential technology in aviation, maritime operation, and traffic control.
My name is Zuleika, and now I'm wrapping up our team presentation. I will cover radar real-world application in weather and defense alongside our key conclusion. First, weather radar act as an essential meteorological tracker by measuring atmosphere relativity. It provides early storm detection and hurricane warning, keeping our airport and community safe. Secondly, military radar serve as a crucial defense shield using early warning network to continuously scan the airspace and intercept strategic threats. Ultimately, radar through strength lies in its core advantage, its ability to operate in any weather over extreme distance, providing instant real-time coordination. To conclude our team deep dive into radar system, it's clear that radio detection and ringing is the invisible backbone of our modern world. Whether it's aviation safety, managing thousands of flights daily, or maritime vessel navigating through thick fog, radar provides the critical vision where the human eye fails. We've seen how the simple principle of measuring electromagnetic echoes using the distance formula allow us to track everything from hundreds miles storm front to a single vehicle on the highway. In short, radar technology has evolved from wartime secret to global necessity, safety guarding life every second of every day.